So let's take a look at a degree 4 polynomial now and see if we can draw its graph. And we're going to sort of plod through this one by plotting points. Our ultimate goal is to be able to sketch these graphs without having to plot a lot of points. So once we complete this example, we're going to have a summary that will be a guide that will help make this easier for all different kinds of degrees. But not yet. Right now we still just want to kind of try to discover what's going on here. So we're going to graph this polynomial, and f of x equals minus x to the fourth minus x cubed plus 6x squared. Sometimes these minus signs are a little bit tricky for folks, so just make sure you're aware that when you see an expression written in this way, you can always think of it as, I'm going to write f of x equals, that's like negative 1 times x to the fourth minus 1 times x cubed, put times in there, plus 6x squared. And the reason I write out the ones is to make sure you realize that the minus sign is separate, is outside of the exponent, the x to the fourth. So you would raise a number to a power first, then multiply by negative 1 for both of those first two terms. Now, all right, let's go ahead and try to find some points here. Let's try to find x-intercepts. Those are points where y is equal to 0, right? So we're going to take the expression for this function and set it equal to 0. It's like setting y equal to 0 and solve for x. And here I can factor out common factor of x squared. I'm actually going to factor out a minus x squared. And then I'm going to have a plus x squared plus x minus 6 inside parentheses if I've factored out that minus x squared. And because I have one side equal to 0 and a product, by the 0 property, either minus x squared is equal to 0 or x squared plus x minus 6 equals 0. Now this minus x squared equals 0, that's the same as saying I can multiply both sides by negative 1, but negative 1 times 0 is just still 0. And if x squared is 0, x is equal to 0. That's the only solution I get out of that minus x squared equals 0. On the right, I can try factoring this trinomial. Let's see, x and an x. It's not too hard to factor. X plus 3, x minus 2. I think that works. So x plus 3 is equal to 0, or x minus 2 equals 0. So I get x is equal to negative 3, and x is equal to 2 here. So I actually have three x-intercepts. I have 0, 0, negative 3, 0, and 2, 0. So that turned out to be pretty successful. I didn't, you know, you might say, why didn't you start with y-intercept first? I guess it's just, if you look for the y-intercept here, if you plug in 0 for x, you're just going to get 0, 0. You're going to get this same 0, 0 point. That's the only y-intercept on this graph. So let's maybe start a running list of the table of values here. For our minus x to the fourth minus x cubed plus 6x squared function, we got our x-intercepts. So we got 0, 0, we got negative 3, 0, we got 2, 0. I guess I might as well plug in 1 and negative 1 into that function, f of 1 is minus 1 to the 4th minus 1 cubed plus 6 times 1 squared. That's negative 1 minus 1 plus 6 is going to be 4. And f of negative 1 is minus negative 1 to the 4th minus negative 1 cubed plus 6 times negative 1 squared. That's going to be minus a positive 1. I just put the plus for emphasis. So do negative 1 to the 4th is positive, the minus sign comes after. And then I'm going to get minus a negative 1, because the negative 1 cubed is negative. And I'm just going to get plus 6 on the end, because the negative 1 squared is a positive 1. So I got negative 1 plus 1 plus 6 is 6. So at negative 1, I get 6. I want to plug in negative 2. And I want to write out this calculation again, just to make sure everybody's comfortable plugging in values to these more complicated functions. So if I were calculating f of negative 2, I save the minus sign out front. First I do negative 2 to the 4th. Negative 2 to the 4th is going to be positive 16, so that will be negative 16. Save this minus sign. Negative 2 cubed is a negative 8, plus I get 6 times 4. So that's negative 16 plus 8 plus 24. And I think that's going to turn out to be positive 16 in the end. And I'm not going to write out these calculations, but I did a couple more ahead of time on my own, and you can check these values. F of 3 is negative 54. F of 4 is actually negative 224. And I want to go ahead and start plotting some of these points on a graph grid. I'm going to set up my scale 1, 2, 3, 4, so 2 squares to a unit on the x-axis to spread out a little bit. But then, so I can fit that 16 on here, I think I'm going to go 2, 4, 6, 8, 10, 2, 4, 6, 8, 20, 2, 4, 6, 8, negative 10 on the y-axis. Okay. And so we got our x-intercepts, right? 0, 0, negative 3, 0, 2, 0, and I got 1, 4. Now this is 2, 4, so 1, 4 is right there. I have negative 1, 6, and I have negative 2, 16, so that's 10, 12, 14, 16 way up there. And then just observe, I kind of have a lot of the graph I can draw. Now, I draw the graph moving from left to right through these points. And now at 3, I have this very negative value. I'm not gonna plot that point. I'm just gonna have the graph plunging down. And at negative 4, I have a negative, very negative value. So again, I'm just gonna draw the graph plunging down. Now, this is only an approximate graph, even though I drew it pretty carefully. I really don't know where these, like some of these turnaround points are. So I suggest you check Desmos. And I want to just show you what I mean by that, by Desmos. I'm pulling up my tablet. And if you have trouble using Desmos, let me know. I entered our function in, and here's the graph I get on Desmos. I'm not going to leave it on the screen very long. I just it's just interesting to see how my graph isn't quite right. Like there are some things off about it because there are things we can't detect. But what I want you to think about is, so here's our example of a fourth degree graph. It goes, notice how it goes up, down, up, down. It has more wiggles than a cubic graph. And it has these points here, here, here. We're going to call turnaround points. And I think I'm going to leave that for the next stage. I guess maybe I'm going to squeeze this just down in at the bottom. Possible shapes for degree 4. Now we haven't investigated all of these, but I just want to be able to sum this up before we go to more general statements in a minute. So kind of the shape we have here is like up, down, like that. We've also seen just like minus x to the fourth can look that way. Sometimes you're going to see something kind of like that. And you also have the reverse of these. So you can go like W shape, the positive x to the fourth shape, and a shape that sort of just has sort of a lump in it. Oh, and I want to make one note about all of these is note the end behavior is like f of x equals, for our example, the end behavior is like f of x equals minus x to the fourth, right? And that's because, let's just go back to the expression for this function. Maybe I better write it here on our, right next to our graph. This was f of x equals minus x to the fourth minus x cubed plus 6x squared. It's going to turn out that that term of highest degree determines the end behavior of the whole function. And for any fourth degree polynomial, the end behavior is either going to be like minus x to the fourth or like plus x to the fourth. So I'll stop there, and then we'll summarize all this we've discovered so far in the next video.